Okay, good morning from Belém, Brazil. Thank you very much online and on-site for your participation in this seminar, promoting use of GOSAT data for climate science outreach and business applications. So I'm Tazusaki, a senior researcher from National Institute for Environmental Studies. So GOSAT is the name of Japanese satellite. Later we will introduce you about satellites. So here is today's agenda. Researchers and specialists from various fields introduce you about Japanese GOSAT satellite series satellite and the international cooperation and the business applications of GOSAT data and education and outreach on greenhouse gas and climate change. So through this seminar, you can find out how the Japanese new technology will contribute to global decarbonization efforts. So to begin with, I would like to invite Mr. Doi, Vice Minister for Global Environmental Affairs, Ministry of Environment, Japan, for opening remarks.
I am Doi Kentaro, Vice Minister for Global Environmental Affairs. On behalf of the Ministry of the Environment of Japan, I would like to thank you all for joining us in this seminar and the National Institute for Environmental Studies for organizing it with the Ministry of the Environment. On July 28th this year, in Universal Time Coordinated, Japan successfully launched its Global Observing Satellite for Greenhouse Gases and Water Cycle, or GOSAT-GW. The satellite has completed initial functional verification and has commenced operational observations. We will proceed with calibration and verification of the data observed by GOSAT-GW and aim to make it publicly available as soon as possible. The purpose of this seminar is to showcase the latest research findings and cutting-edge initiatives in climate science utilizing greenhouse gas observation data, including that from GOSAT-GW, thereby promoting decarbonization efforts by countries and companies worldwide. The first half will feature presentations by various experts, followed by a panel discussion in a latter half. Presentations will begin with an introduction from NIES about the Japan GHG Center initiative established to disseminate greenhouse gas observations and the latest scientific findings globally. This will be followed by presentations from researchers in various countries on their effort to disseminate the greenhouse gas information and reduction methane emissions. Additionally, new initiatives from the private sector utilizing greenhouse gas observation satellite data will be introduced. Applications are planned across diverse fields, including finance, insurance, education, and satellite development. Following presentations, a panel discussion themed expectations for this GOSAT-GW and dissemination of information and findings will be held featuring experts from various countries and fields. The panelists will discuss expectations for GOSAT GW, further developing greenhouse gas observation, and the utilization of its data. The GOSAT series has earned high praise from climate science, the private sector, and partner nations for its data continuity and accuracy. GOSAT GW will deliver information on greenhouse gases that is unprecedented in detail. The Japanese government will use the GOSAT series to enhance transparency under the Paris Agreement and contribute to regional and corporate reduction efforts toward achieve net zero by 2050. Thank you for your attention.
Thank you, Mr. Doi, for kind opening remarks. Next, I'd like to invite Dr. Hiroshi Tanimoto, who will speak about GOSAT GW data for more detail.
Thank you. Can you hear me well? So noisy, right? But I hope you can hear me well. Good. Okay, so thank you for coming. It's really great to see all of you, like old friends, new friends, I mean, global community, global colleagues. And I would like to start my presentation with, say, the best movie of the year, this year, which is, of course, the launch of GOSAT GW satellite in June 2025. So rocket launch is hard, and it's always exciting and impressive. But remember, our job did not finish with the launch. Rather, did start with the launch. So we have a big ball, and we have to keep loading the ball, which is, of course, carbon neutrality. But that goal is really far, and big ball is really big. So we need to work together. I mean, hopefully you join us. Good. So now satellite observation is really playing a big role in these climate change mitigation policies. You see here a lot of satellites, including global GHG mappers and also facility scale proof monitors like GHGSat. So GOSAT 1, 2, and now we have GOSAT 3, GW. So you can realize that Japan is playing a big role and really willing to contribute to the observations based mitigation. So GOSAT GW was launched back in June 2025. So it's not yet even 5 months or 6 months. So it's really like for me, it's like a yesterday or say last week. And we scientists at NIES are really working so hard to make it data available as quickly as possible. So as I said, GOSAT GW is going to make measurements of CO2, methane, and NO2 on a single platform that's really new and unique observations. And we have 2 observation modes. And the first one is wide mode, which you can see, I don't know, pointer here. Here? No. Anyway, wide mode. It's nominal observations, which makes 3-day global coverage of these species. And optionally, we could have focus mode observation, which we can target specific cities, large emission sources, or whatever we want to look at. So 3 mission requirements. The first one is to monitor whole atmosphere global mean concentration of CO2 and methane, like how we can track increasing CO2 and methane concentrations, like a Keeling curve at Mauna Loa. And the second one is to verify country level and subgenic emissions reported to UNFCCC, which is really relevant to COP objectives. And third one is really new for us, detection of greenhouse gas emissions from large emission sources, such as mega cities like Tokyo or power plants and permafrost. So that's really big challenges for us, and we would like to make it happen together with you. So let me show you first slide, which JAXA made in July, 3 days in July. So you can see 3 days coverage globally with wide mode, and you can also see focus mode observations over Tokyo. So that's really looks promising. But this is not CO2, no methane, no NO2, but I'm really excited to show you these first results of co-located CO2, methane, and NO2 from GOSAT GW. This is from focus mode observations over, say, locations in Northern Hemisphere. You can guess where it is. Maybe you can guess. Some cities in US. So it's really nice. I mean, 90 kilometer swath, smart focus area with, I think, 3 by 3 kilometer resolution, spatial resolutions. So I'd like to, I have to say, this is really initial analysis based on preliminary data. So maybe this is enhancement of from emissions, or maybe some albedo stuff. But I would like to appreciate these young folk scientists at NIES, Yuso Miya, Tamaki Fujinawa, and Hyungan Rim. They really make it happen for COP today. So let me, thank them for their hard work for that. Okay, but GOSAT is not only the thing in Japan. We have a whole lot of details, many activities and operational research activities. And many of these are contributing to scientific support for policy-making processes. NIES, National Institute for Environmental Studies, and Ministry of the Environment, we are having environmental focus. NIES is doing research-based long-term monitoring and also Japanese emission inventory. Yeah, it's here. Of course, we do GOSAT and carbon cycle modeling like this. Ministry of Environment is responsible for climate change policies, including mitigation and adaptation, and also GOSAT series operation and funding. So we do GOSAT series together. JMA, Japanese Met Office Meteorological Agency, and Meteorological Research Institute, we call MRI, are having meteorological focus, of course. So JMA is doing operational monitoring for GAO and also maintaining database called WDCG, G. MRI is doing research complementing to observations, operational observations by JMA, and also they join contrail aircraft measurement and also modeling effort by RECAP and Transcom. With that. Other research agencies, national lab called JAMSTEC is having ocean focus, and JAXA is of course having space focus. They are under MEX, which is Ministry of Education, Culture, Sports, and Science and Technology. So they have a research and development focus. And JAMSTEC is making research vessels observations, carbon cycle modeling, GOSAT GW modeling. And JAXA is responsible for GOSAT series level 1 data products, and also doing long-term vicarious calibration for space-based greenhouse gases, including OCO2, 3, TOPOMI, and TEMPO. So now you see we have a whole lot of details, and we believe we are doing this because we believe evidence is important and knowledge is important. But challenges for us is how we could deliver this information to society to drive actions. So that's a big challenge for us. So therefore, we are now discussing to launch a Japan Greenhouse Gas Center. We're still discussing and to make it happen soon, hopefully. But you see here, better information, we believe, is driving for a better solution. So 3 high-level objectives include one-stop information hub for scientists, policymakers, and business leaders. Yes, they're here now. Bank and insurance companies are joining us. And also, this is a multi-agency institute efforts for all Japan, one team to serve for global society. We will focus on, say, integrated assessment of greenhouse gas emissions and fluxes, because we believe this is important for climate change policies. So flux or emissions, like this, in case of methane, here, by using models, we can derive information like anthropogenic emissions of methane, highlighting Asian emissions are really contributing a lot. And also natural wetland emissions are also a big player for methane. And one thing I would like to show you in the last is flux information for country-specific comparisons. Say some specific countries as examples here. And blue dots are top-down estimates from inverse modeling with GOSAT satellite data in comparison to bottom-up emissions reported to UNFCCC. So sometimes they match well, sometimes not. But this is really like a great information for us to help understand why this is, and leading to accurate information and knowledge to drive actions. So we can see the opportunity really satellite is really complementing to bottom-up emissions with models. So yeah, finally, I'd like to touch a little bit about international collaboration on methane, in particular IMEO and GHGSat. We can do this like say co-located observations together with GHGSat, Stefan is talking later, and NIES and MOE will start sharing preliminary TANS3 data to external partners in January 2026, which is really coming soon. So we're really excited. I hope you get excited too. And I already promised with many stakeholders, METI, JOGMEC, for IMEO, for methane emission reduction policies. So that's really coming soon, and we would like to push it further, but we need your collaborations, and I would like to thank your attention for my talk today. Thank you very much.
Thank you. GHG observation from space, Mr. Japan probably. So now he prepared his slide. Please wait for a while.
これです。はい。で、3番目。はい。
So, my name is Frank Martin Blackwood. I'm working for the European Space Agency in the Observation Center Tuscany, south of Rome, in Italy. And I'm happy to be here. It's a very intense talk and one side event and one obligation is coming up each other. But I'm specifically happy to be here with my friend from Japan and would like to talk a little bit about our cooperation. Let's see. Okay. So, first of all, it is a historic and long-lasting partnership. ESA and Japan are working together for a long time, and the cooperation is continuously growing. We are getting stronger and stronger. Just give you some examples. We have related to the Copernicus Corporation Group with a strong focus on greenhouse gases. Japan is a member. ESA-JAXA collaboration resulted in 2024 in the launch of the joint Earth Care mission. JAXA, and of course, coming from ESA space agency to space agency, that is our closest partner. But we have many other partners in Japan. We are working together with NIES, with JICA, with LEGTEC, and so on. So there are a lot of partners in Japan. In 2024, we jointly signed a framework agreement for the strategic partnership on climate action. Well, and in the field of international cooperation, there are joint efforts in engaging with IPCC, UNFCCC, and COP. We have had many side events together, organized between Japanese organizations and European organizations to advocate and advertise the use of Earth observation data to combat climate change. ESA are strongly collaborating in the Committee of Earth Observation Satellite field. And JAXA just has finished its mandate to be the chair of the strategic implementation team, which was strongly supported by ESA. Jointly with NASA, we circulated an annual workshop on greenhouse gas from space between Europe, Japan, and the Americas. collaboration on greenhouse gases. Japanese and European teams are closely collaborating to maximize the usage of greenhouse gas products from GOSAT, GW, and all the Copernicus missions, Sentinel-5P, Sentinel-5, CO2N, which is going to be launched in the near future. GOSAT GW has had a beautiful launch, and I'm always excited when I see a launch of a satellite. It's emotionally always a big impact. Now we are waiting to initiate the collaboration further on calibration, validation, and integration of data into other data streams, compare it with other satellites, and bring all these wells of data together to have a better knowledge of greenhouse gases in the atmosphere. Those new developments will be strongly supported from our team within Europe. But now let me come to something else. Greenhouse gases are not only observed in the atmosphere, we see the emission of greenhouse gases as well from the land sector, specifically Apollo. Biomass is one of the activities, and for biomass, we are strongly collaborating together with JAXA, bringing together European satellite data, Sentinel-1, and Japanese satellite data, the ALOS time series, to come up with a time series of biomass estimation globally, which is unprecedented in quality, in resolution, and in the length of the observation system. Why I'm saying this? Because the goal as well within TIOS is to bring together the observations from bottom up from the land with the observations what we see in the atmosphere. And GOSAT GW will be another key element in this drive for information. 6 months ago, we renewed the memorandum of understanding to work stronger together with in relation of climate change that was happening during the Living Planet Symposium in Vienna in June this year. Thanks a lot.
There. First of all, can you hear me well? Can you hear me well? Is it better? Okay. First of all, it's a pleasure to be here, Vice Minister. It's really an honor for me to be here on behalf of the United Nations Environment Program and the International Methane Emissions Observatory. I see a lot of partners, colleagues, and experts. Disclaimer, I'm not an expert, but I'll try to do my best to go through the presentation since IMEO, the International Methane Emissions Observatory. Thank you. Is within my purview. My name is Ruth Couto. I'm Brazilian, and I have been working for UNEP for a long time, and IMEO is under my jurisdiction. I'm the Deputy Director of the Climate Change Division in UNEP. I don't have to tell you how important it is to reduce methane emissions in the short term. This is probably the most cost-effective action that we can have over the next 10 years. Methane is contributing to around 1/3 of global warming. And within the oil and gas sector, there is a wealth of possibilities that are low cost to reduce emissions. what we do in the International Methane Emissions Observatory, is actually to gather data very similar to what you're going to do with GOSAT and what the European Space Agency is doing from different sources, combine and integrate. So from satellites, from measurement studies, from empirical data, from actually measurements with drones, and the devil is in the detail because we need to integrate all this data and actually spit out something that is palatable and that somebody can actually act upon. Who is this somebody? The industry, the oil and gas sector, government with evidence-based policy making, and also other stakeholders. I was talking to Germain before, actually, and he was trying to convince me that satellites are so important. I'm convinced, of course, and they actually provide very accurate data. And we have seen in your presentation the focus mode of GOSAT GW, and this is going to be extremely important for us to advance some of the products that we are doing. We're going to have much more precise information with the level of accuracy and detail that you provide to us, and we'll have much more reliable products. What we're facing today, when we integrate the data, and we do integrate, I'll show you in a minute, 17 satellites, we have sometimes some false positives, especially when we use artificial intelligence to validate the data. And the capacity of GOSAT GW to go to higher latitudes to avoid this issue of having snow reflecting and giving us the false positives, but also other wet areas and cloud coverage and things like that. And I have seen how important it's going to be for land use and waste, and all this is very important for us, for our integration and for actually the overlapping of data and the validation. This is our, actually, we all have that kind of slide, which satellites we're using. We will add to our constellation, GOSAT GW, with some very good specific features. We also are still collecting data from, unfortunately, the methane set that was lost, but we still have data for that. And I was also very emotional when I saw the launch of the satellite. I think it's a lot of work to launch, but now the work begins to get the data, and we're going to work. This is our constellation of satellites. As I said, we also do some studies where we use satellite data. We can do studies that we actually can do the measurements on site and with drones, but also using satellite data to do our studies. We're having 15 studies at the moment using satellite data, and we're actually going to start 10 more for next year. This is very important. Why? You have seen in, sorry, I forgot your name, but your very important presentation, the difference between what is being reported to the UNFCCC and what is being actually served by satellites. If this information, and we believe is correct, we are underestimating the methane emissions globally, which is very dangerous, which means that our global warming is not actually 2.5 if we continue in this track. Hopefully we'll aim for 1.5, but it's more. And if it's more, we have to do more, and do more quickly and now. So we're being underestimating, but it's important because it gives you the information of where the emissions are taking place. And this allows us to act with much more diligence, I would say. We also have a platform that I mentioned to the Vice Minister this morning. It's called the Methane Alert and Response Systems. We call it MAR. It actually gathers all the data from satellites where are the very large methane leakages. We have been working with that, and so far we have identified more than 4,000 alerts. Out of these alerts, we inform focal points that we actually have in our system of where are these emissions coming from. Most of the emissions that we are actually informing are related to the oil and gas sector, because we also do have an oil and gas methane partnership, that actually has around 150 companies that covers around 40% of the oil and gas production worldwide. And therefore, when we inform them, they can actually take action if there is an oil and gas related methane emissions in their actually sites. It could be a flaring, it could be a vent release, it could be, but it normally shows that the operations are, the maintenance of that operation is not up to the level that one would like to see, and therefore there is leakages. We have seen leakages in Central Asia for years when we look into the satellite data and we compare. So it's very important to identify these sources and to act upon them. However, what we have been struggling with is with the response rate. We do inform the stakeholders, but the action that will actually take place takes a long time and sometimes doesn't even take place. And so we need to think together, everybody that is working in this field, what we can do together to improve the response rate, because the satellites are extremely important, but for us to actually address the issue of leakage of methane, flaring, etc., we need the companies and sometimes national oil companies that we're discussing to take action. And this is a very important issue because that's where the mitigation will take place. GOSAT is going to be very useful for us because there is going to be geological studies on basins of oil and gas actually production. And GOSAT will help us with the focus mode to improve the methane emissions index that will quantify emissions along the supply routes or as a basis for importers and policymakers. And we'll work on a basin level. So this is something that is a product that we're developing for next year, and we're going to regionalize it as we're actually trying to do, but also at the country level. So we can bring all these information together and give whoever is actually interested in the information much robust information. Finally, we cannot do this alone. We have to work in partnership, and you are all working here, and we really would like to appreciate all the partners that we have, but specifically this new cooperation we have with Japan, because we believe that the GOSAT GW will allow us to go further. We're also discussing cooperation with the GHG. Forgot the last name of it. GHG, but GHG-SAT, and we're going to work together with also the European Space Agency and other partners to advance this issue. In UNEP, methane is a top priority, not only through the work that we do on the International Methane Emissions Observatory, but also to the Climate and Clean Air Coalition that works with short-lived climate. Thank you very much for this opportunity and for the Raise the Flag or Cut Methane. Thank you very much.
Thank you, Rose. Very important work for IMEO plan. So next we move on to business application section. The first is Mr. Keisuke Yano from Sampai Insurance.
Hi, my name is Yano, and I'm in charge of new product development at Sompo Japan. Today, I would like to explain a new service that was announced in August of this year. We believe that this initiative will particularly contribute to the decarbonization of the LNG supply chain. Here, we have summarized the external environment and the company's situations. In addition to the risk of the methane leakage itself, the risks to the companies include the risk of fine overseas and the risks of criticism from the third parties. The risks surround companies that emit methane can be categorized and listed below. I won't go into all of them now, but it is necessary to face risks on many fronts and consider countermeasures. These are the risk solutions we recently announced. Please look at the box above. First, our cargo insurance policy holder can receive a free simple methane emission risk report based on satellite imagery analysis. We confirm emission status as one of the risk information when underwriting insurance, and we also provide this information to our clients. This simple report is created by our group company, Sompo Risk Management. Please look at the additional option box below. After getting a rough understanding of emission potential from the report above, JGC and Momentic will provide even more valuable solutions. JGC can provide everything from methane emission planning to on-site measurement and consulting services. Momentic uses its software to analyze high-resolution satellite imagery to provide reports that can identify the emission sources in more detail than the simple report. This is a simple methane emission risk report I explained earlier. We provide reports that analyze emission events over the past several years in line with the start and renewal of insurance contracts. Currently, we use satellite data that is already available, such as Toropomi, for our analysis. But when GOSAT GW data becomes available, we will also analyze that data and create reports. Companies that use this report can publicly announce that. A company that use this report can publicly announce that they regularly monitor methane emissions risks using satellite imagery. We are considering a special clause called the methane leak damage prevention cost special clause. Under this clause, if emissions exceeding predetermined level and discovered in the simple report, part of the cost of additional investigation will be covered by insurance. Company can use this money to cover the costs of advanced solutions offered by JGC and Momentic. In this way, we will promote risk solutions, including insurance, and contribute to the decarbonization of supply chains. Next, Momentic, who plays an important role in this solution, will explain their technology. Daniel, please.
Hi everyone. I'm Daniel Kashmir, founder and CSO at Momentic. So happy to be here with our partners from Sompo. We'd love to tell you all about Momentic and how our technology helping energy and insurance company to monitor emissions and eventually reduce risk. So a little bit about us. Momentic is an emission intelligence company. We created a unique algorithm, accurate and autonomous algorithm that providing to energy companies full identification and quantifications for greenhouse gases and methane specifically. Momentic is 100% software company, and we are multi-satellites companies as well. We are providing emission rate with how much kilogram per hour can we see, exact locations of the emissions, And if we can see some problems over there or emissions, we have up to 7 years of historical data. So we are providing more and more insights to the customers. And next slide, please. So we are providing the same solutions to the waste management domain as well. Over there, again, just type the name of the assets or coordinates that you want to monitor a day after. You can see if there is emissions or not, the quantity, the emission rate, and again, the exact locations of the active places over the landfills. And next slide. Over the coal mines domain, again, over there, we are providing the exact location. Sometimes it's multiple locations of emissions, small plumes, but eventually we are helping coal mines owners to prevent explosions and disasters. Next slide. So the second offering that we are providing is large area monitoring. And over here, it can be a different kind of use case. It can be a long pipeline from one side of the country to the other side. So again, because we are software, we are combining a few large satellite images and provide our customers in days the exact locations of the leaks over the pipelines. So this is an example of large area monitoring services. Next slide. Here. This is just an example of oil and gas sites that we are providing a monitoring service to. So it can be any type of oil or gas facility. It can be a storage terminal, large one with hundreds of different storage tanks. We are providing the exact ones with problems right now. Again, long pipelines on the bottom, exact location of the leaks, any kind of compressor station or other kind of facility. And next slide, please. So this is our value proposition. So we are helping our customers to reduce greenhouse gas emissions, helping them with compliance on regulated market, helping them to reduce revenue loss from methane leaks, and eventually, specifically to our insurance partners, we are helping them to prevent explosions, improve safety on ground, and manage their risk. Next slide, please. This is the main advantage of our technology. So again, we are a multi-satellite company. We are providing global coverage, software only, no integration needed, and it's a huge advantage. We can cover large area monitoring as well, and not just pinpoint up to 7 years of historical data. We can cover offshore rigs, offshore facility as well, with all the complexity over there, and eventually it's a cost-effective solutions. We're looking forward to continuing our successful collaboration with Sompo and any other industry partners. Thank you.
Thank you, Daniel. So next, we will invite another company from Takumi Hashizume-san from MUFG Bank.
Thank you very much.
Can you hear me? Can you hear me? Well, so please feel free to take off your jacket if you feel hot, because we are talking about the global warming. So, so let's get started. So, my name is Takumi Hashizume from MUFG, the biggest finance institution in Japan. And we opened the first branch in Brazil in 1919. So over 100 years of history in Brazil. So I'm really honored to deliver the speech today. Thank you. And let me introduce our carbon neutrality initiatives. So we have been published a white paper to do it. And this year we will preparing the new one. And white paper 3.0, we mentioned about the new value that objectively measurement of decarbonization identifies using satellite. So from here, this is a kind of the update from the COP29. And the first one is the GHG reduction through fuel change using hyperspectral sensor and in collaboration with NYK. And we monitor the reduction of the GHG emission from objectively from outside. And we are now improving the accuracy on that. The second one is GHG absorption by forest in collaboration with JAXA. This is almost the same meaning is that we evaluate nature capital itself. We have been almost completed the study in Japan. And this fiscal year, we will expand this activity to overseas. So this is today's main topics. Thanks to the strong initiative of the NIES and Ministry of Environment, and in collaboration with GHDSAT and Mitsubishi Electronics and the SDS. And we are now developing the new scheme, which called observation scheme, which called chip and cube scheme. So we will use GOSAT GW to observe a wide range of area. And we find once we find out potential methane leaking area, we deliver its data to GHDSAT, and they will capture the data in pinpoint using their satellite, and we deliver and we sell it to the client and the government and also finance institution. So here is an image flow of our tip and Q scheme. And the GOSAT GW was successfully launched the end of June. And we are still waiting for the data bits because they need more preparation. I'm not pushing the Tanimo-san's team. So for the good preparation, so we simulated GOSAT GW image using Sentinel-5P and GOSAT 2 data to progress it. And through those activities and the studies, we found out the good ideas. So the good findings that I don't mention about the detail of technical things today, but simply say a satellite can't easily observe the onshore, but offshore is really, really difficult. But we, under some condition, we successfully observe the methane leaking hyper emitter offshore on the sea. We strongly believe that this is gonna be a strong tool to observe entire GHG emission in the future. So this is a future action. We are partnering with JOGMEC to develop full stack satellite methane MRV solution ready for global methane regulation such as OGMP 2.0. So we believe that GOSAT GW potential because it's bringing us a transparency. Transparency is key because today's discussion is not like that we have a good purpose for the carbon neutrality or we are creating good products for carbon neutrality, not like that. This is a discussion, how we create the impact together. So I believe that we have to reimagine our socio-industrial ecosystem to foster carbon neutral initiatives. And on those systems, we work well because we are the finance institution, one part of socio-industrial systems. And I needed to stimulate the finance and investment to contribute it. It's because in real world, in reality, for the business, finance is important to make your business sustainable and scalable. So I'm big believer of GOSAT GW and the Japanese technology, knowledge, and the willpower. So to make impact for future generation in the future, in the world. Thank you so much. I'd like to pass my the presentation to our important partner, Stefan-san.
Thank you very much. And it's a privilege to be here with you today and be here with our partners at SDS, at MUFG, and collaborating with NIES and Vice Minister. It's a pleasure to be here. So at GHGSAT, you've heard all about the collaboration that we've had in Japan for the last couple of years and what we're trying to do now with GOSAT GW with methane. And I also would like to expand that now to talk about what we do with carbon dioxide. In a minute. Okay, well, while we're working on the slides, I will tell you about the methane detection that GHGSat does. So today, GHGSat has 12 methane monitoring satellites on orbit, and we have one carbon dioxide satellite on orbit. Like others, I'm very excited by satellite launches, and I'm pleased to tell you that we have 2 more launching next week. So that will be of SpaceX out of California. And so we look forward to having 14 methane monitoring satellites as of next week. In 2024, we had over 4 million facility measurements around the world with our 12 satellites. We did that in 110 countries. And we measured emissions all over the world, from oil and gas, waste management, coal mining, and even agricultural sources. So many, many different types of sources. And that data then, going back many years, can be combined with public satellite data. So not only do we have our own satellites, but we also work with many of the public satellites to provide a complete view of everywhere in the world that there are methane emissions. I think we're almost there. So in addition to what we do for methane, we also work on carbon dioxide. And carbon dioxide, although, as we've heard earlier, it is the largest or most important greenhouse gas, methane in the short term is the one we can act on more quickly. Oh, there we go. Thank you. So with carbon dioxide, we have been monitoring on a more limited basis as we have been validating our first satellite and demonstrating the technology. So in 2024, we focused primarily on emissions in North America and measured thousands of sites in North America for validation purposes. Most of our work for carbon dioxide over the last year has been in collaboration on validation purposes. So we worked in North America monitoring about 36 sites with hundreds of measurements to detect approximately 35 plumes that we then compare against continuous emissions monitoring systems on the ground to validate the accuracy of our measurements. We then also expanded that work to work collaboratively with the European Space Agency to now look at many different satellites and compare the satellites to each other and have several different teams, in this case, 3 different teams, independently retrieving data from the satellites in order to compare the performance of each of the different satellites. And in this case, we're looking at about 10 different sites and about 100 different satellite measurements. So this allows us to not only, on the left, do our own validation against ground measurements, but also on the right, do independent validations with independent scientific teams to rigorously validate the performance of our satellites. We do that for methane, and it's a very important part of the credibility of our services to our customers, industrially and government. And we do that also for carbon dioxide. So today, the highlight, of course, of the discussion is collaboration between different systems. We're looking forward to collaborating on methane with GOSAT GW, but we're also looking forward to collaborating on CO2 with GOSAT GW. And I believe that work will start very shortly. So thank you very much for your support and attention, and we look forward to collaborating with Japan going forward.
Thank you, Stefan. I'm sorry for technical trouble on your first slide. Next, we will invite Dr. Masayuki Kondo, who will talk about the importance of education.
Right. I'm Masayuki Kondo from Hiroshima University. I'm going to talk about educational side of greenhouse gas
So we like to have a framework for the nationwide educational program of climate change and greenhouse gas in Japan. As the director Tanimoto introduced in his presentation, Japan Greenhouse Gas Center will be launched sometimes very soon, hopefully next year. And responsibility of Hiroshima University is to establish nationwide educational program. And in Japan, there are research institute and universities, some covering some specific, but others covering a broad topic of greenhouse gas and biogeochemistries, including eddy flux measurement, greenhouse gas measurement, ecosystem modelings, inverse modeling or system modelings, and greenhouse gas budget assessment. And we have, the cutting edge resources in greenhouse research, and that can be used for education. But we have our own problem. Oops. Oops. I guess it's freezing. Okay, while we are working on it, let me tell you the issue in education in Japan. Also, we have, oh, good. Is it coming? Okay, while we have, research resources, we don't have much of a young scientist in Japan anymore. Okay, I'm in the late 40s, and I'm still the youngest, I guess, in Japan's community. And we need to, oops, it's coming. All right, let's see. It's not moving. Okay. All right. And we need to develop the educational program, and we need to start at very early stage of career, say when students in high school. So we like to have a thorough educational program starting from high school, and our center is going to provide educational seminars covering specific topics and also the more general topics about greenhouse gas and climate changes. And that will provide a high school student to have opportunity to which university they like to go to, which specific topics they like to study in the university. And at the undergraduate level, we can also provide the educational program which is designed for their level. And after that, students can provide which graduate school they like to go to. And even after that, we can provide a matching between the PhD student who about to complete their thesis and the job opportunity opening at the university and the research institute. We like to we can provide the matching for students and research institute, even universities. Still not working. Oh. Okay, and I think there's another thing at universities. We like to, in Japan, we have really nice research resources, but we like to, this is very common in Japan, we like to work independently. We are very bad at working together. So this is the initial attempt to, bring us together, at least provide, more integrated educational system to young students. And hopefully nurture their careers and provide a more broad network within Japan. And at the Hiroshima University, we've been working on the prototype of nationwide educational system. So we started the educational program starting from the high school student to undergrad, and also the graduate level student with of Japan Greenhouse Gas Center. And Japan Greenhouse Gas Center, they will provide a program. Good. Okay, good. So you're working on it. Okay, so let's go to the next one. Let's go to yes. I already talked about this, so let's go to next. Right. Next. Please go down, 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 down. Please. All right, good. So okay, one above. The Hiroshima. Oh, that's one below. That's okay. That's good. That's good. Okay. So Hiroshima University initiated that program called the STELLA program and the support of Japan Science and Technology Agency. And we invited young junior high and senior high school students to have a work experiment at Hiroshima University, and we provide a research opportunity to them and work together and provide a lecture. And we've been doing several years, and we gone through a several selection process. And initially we have 250 students, and we reduce it down to 30 students. And they're supposed to be the great prospect, I guess. And we provided that introduction to climate change. I did that myself to those students. Have discussion was so lively. It was great sessions. Okay, please go to next. And this is the core of Hiroshima University's attempt on carbon neutrality. So this small island is called Osaki Kamishima. This is isolated island. And we have set up the multiple experiment on carbon neutrality. And we have experiment on increasing carbon storage capacity on blue carbon and green carbon. And in addition, very important thing is that island has power plant. And we have succeeded in making a system of capturing 90% of CO2 emission from power plant. And that's not the whole story. So we also making use of that absorbed CO2. We make methane by microbial fermentation process using hydrogen, and then we make methane. And with the methane, we can make a chemical product and fuels. So this is, only experiment in Japan so far, to my best knowledge. And we've been using this experiment on this island. We provide a lecture to students and experimental opportunity to them. Please go to next. All right, so I already talked about this. So Greenhouse Gas Center will have the academics starting from next fiscal years, users of GOSAT series data for education. And last slide, please go next. Okay, so we should, involve international community as well. So this is the ILEAPS Open Science Conference 2027 announcement. So I hope you know about ILEAPS. ILEAPS is one of the 25 global research networks and the features. And ILEAPS stands for the Integrated Land Ecosystem Atmosphere Process Studies. And Hiroshima University will be the host of this conference. So March 1st to March 5th, 2027. Please keep note on that. And I'd like to invite young students, and this can be a very good opportunity for young students or young scientists to shine. All right. Thank you very much.
Thank you, Kondo-san. I'm sorry again for your technical trouble. So next we have a time for panel discussion, but we run short of time. So Hiroshi will moderate the panel, but how do we do?
Good. Okay.
Next, please.
So we had a really great discussion presentations, and it's always like we are running, time scheduling is always complicated, and it's not natural. So no worries. But if you have any questions or comments, or you want to say more, a little bit more, you can. We have just a few minutes. I mean, like I don't know, 5 minutes or so. Questions maybe. And Taz wanted to say a little bit on this, but no questions. No, no. Or maybe I'd like to invite Ministry of Environment. Okay. Maybe she wanted to say something.
Yeah, I'm sorry. I'm just to introduce you about the GOSAT data availability. So we, NIES, is providing you our GOSAT data from our NIES website. So all data is freely available from our NIES website with registration. We needed to your email address for registration, but otherwise they are free. So now we are open for GOSAT and GOSAT 2 on our website, and we are preparing for GOSAT GW data to distribution to you. So for more detail, please visit our UN official exhibit booth number 46. Thank you very much.
Good, thank you. 5 minutes, yes. We still have 5 minutes. Good. We need to have some time to take pictures. So maybe, I don't know, 3 minutes. Okay, maybe I'd like to invite Mr. Nagamori, or Dr. to be soon, from the Minister of Environment to say a few words. Microphone, maybe, please.
Thank you, Professor Tanimoto, and thank you for great presentation from various aspects, business application and academia. I had one comment to add. As already speakers mentioned, the expectation of the GOSAT is quite high, and GOSAT series is already highly regarded among the academia and the scientists because of its continuous data release and the high quality data. GOSAT GW data will be so well. So yeah, what I like to emphasize is that at the moment, the GOSAT series is the only satellite system in the world which can observe both methane and carbon dioxide, while also providing its data to the public for free. So we hope that this seminar and the relevant partnership will encourage a wide range of stakeholders to use GOSAT series data. Thank you.
Okay, thank you. Great. Starting this seminar is tough, but finishing is also tough because we really had a great discussion. But we see each other next year or hopefully sooner, and maybe we have some progress together. So good, thank you. So maybe we should take a group picture together. I don't know, speakers or only speakers because of some, I don't know. Okay, so speakers, can you come up to the front?